Hello people, this is the fifth problem from INMO 2000, INMO 2020. So let me read the problem statement. Infinitely many equidistant parallel lines are drawn in the plane. A positive integer n is greater than or equal to 3 is called frameable if it is possible to draw a regular polygon with n sides all whose vertices lies on these lines and no lines contains more than one vertex of the polygon. So we have to first show that 3, 4, 6 are frameable, any integer greater than 7 is not frameable, and we have to determine whether 5 is frameable or not. So this is a very interesting problem. So let us first do away with the construction. So I'm not going to spend much time on it because it's simple, you can figure it out on your own. So to show, I've already got a diagram here which shows that this is 4 and this is 6, and note that 6 already includes the case of 3 because this triangle here is a triangle, and because the hexagon is frameable, this triangle also gets frameable. So 6 comma 3 both are included here. So this proves the first part. I borrowed this diagram because it's not very hard to prove, and so we basically move on to the next part, B and C. So what the problem actually states is that there are some parallel line given, and we have to draw regular polygons such that each of the vertex lies on one of these lines, and these distances are equal. So these distances are equal, and we have to draw the polygon in such a way that first of all it is a regular polygon, which means that every side should be equal and every angle should be equal. So suppose this is r, this is also r, and every angle is also equal. So I am doing a dotted diagram because it could be an n-sided polygon, and we have to determine for which n is it possible to construct such a polygon. For which n is it possible? It's possible. That is basically the question. And the question already says that prove that n greater than equal to 7 doesn't work. So any integer n greater than equal to 7, regular n-gun is not possible. So that is what we have to prove. So this is the basic thes thesis of the problem. So let us move, excuse me. So let us move on to the solution. So notice that the regular n-gun would be something like this, and dot dot dot, each of the n sides are here. So what I'm doing is I'm considering the lowest point here. Lowest points means basically the most down point in the parallel lines. So suppose in the parallel lines, this is this point. This point n is the lowest point. So what would happen is there are basically two lines emerging out of it, and this would be something like this, and dot 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 dot. So let's suppose that this angle here is alpha, the angle it makes with the parallel. Before I start, I've made the assumption that this particular distance is equal to 1 because they are separated and we can assume any distance without loss of generality. So let's assume that this distance is 1 between any two parallel lines. So what we do is, first of all, let's not call it n, let's call it a1, a2, a3, and so on. And what we do, we consider a1, a2 as a vector. So a1, a2 vector, and this a1, a2 vector I denote by r. So this is the r vector, which is this, with this is a vector facing this direction towards a2. So what is the inclination of r to the coordinate planes? Clearly it is alpha. So a1, a2 vector equal to r vector, and the angle is alpha. This alpha shows that the angle with the x-axis is alpha. So And notice what would be A2, A3 vector. Hmm. So suppose this external angle here is theta. So clearly the inclination of A2, A3 is this the magnitude would be the same because it is a regular polygon, and the angle here would be alpha plus theta. So basically the first vector makes an angle alpha and the second vector makes an angle theta with the first vector, because see, this is a1 a2 vector and a2 a3 vectors makes an angle theta with a1 a2. So a2 a3 would be r alpha plus theta. What I am doing r alpha plus theta is that the magnitude of the vector would be the same and alpha plus theta denotes the angle of the vector. So this should be pretty much clear. So we can proceed in a similar manner by a3 a4 would be r in alpha plus 2 theta and so on. See, basically each time we move from one vector to another vector, there is a rotation of angle theta here. This angle is theta, so theta theta gets added up, and lastly a1 vector, which is the last vector, would be r1 vector alpha plus suppose some k theta. And one thing to note is that if we again draw a1 a2 vector from a and a1 vector, it could be written alpha into a plus k, alpha plus k plus 1 into theta. And notice that this alpha plus k plus 1 theta, this angle is equivalent to angle alpha. So we can conclude that k plus 1 into theta equal to 2 pi. So basically 2 pi means a complete revolution around the circle. So basically the vectors keep on rotating, keep on rotating, keep on rotating, and finally reach the original vector, which is alpha. So total rotation is k plus 1 into theta, and that is equal to 2 pi. So also theta can be calculated very easily, because suppose it is an n gun and the outer angle of an n gun is given by 2 pi by n. This is pretty easy to calculate. So this is 2 pi by n. So we keep in mind that theta equal to 2 pi by n. This is basically what we have here. Let me draw it in a circle. Sorry, let me draw it in a box. So this is what we get. And by the problem conditions, see, notice that suppose this is an n gun. Let me draw another n gun. Suppose this is an n gun. So see, these are all parallel lines like this, like this. So these all distances are integers, positive integers, because by the problem condition they are equidistant lines, and I have considered that the distance between two lines is 1. So these are all integers. So what this basically translates to is that suppose this is r, this is r as I have told earlier, and this is angles theta suppose. So this basically translates to r sine of angle theta. Suppose this is, let us denote by another angle, x suppose. So r sine x should be an integer. So r sine x should belongs to z, because r sine x denotes the parallel line distance basically. So r sine x belongs to z for all x. So basically what this tells us is that r into sine of alpha belongs to z, r sine of alpha plus theta belongs to z, and we keep on going, r sine of alpha plus 2 theta belongs to z, all of them are integers, and so on, r sine of alpha plus k theta belongs to z. This is what we get. So these are all integers because parallel lines are integer distances between them. So using this, notice that we don't know the value of r and we don't know the value of alpha. The only thing we know is the value of theta from the value of n. So what we do is we try to eliminate, our strategy is to eliminate r and alpha. So this is what we want to do and obtain a relation using theta only. So notice that first of all, one thing to notice is that k plus 1 into theta equal to 2 pi, as I have proved way back. K plus 1 theta equal to 2 pi. So this is the fact we are going to use. And notice that first of all, another thing, if A belongs to Z and B belongs to Z, C belongs to Z and D belongs to Z. Suppose four numbers are integers, then A minus B upon C minus D should be a rational number, because division cannot make a rational number irrational basically. So this should be a rational number. What we do is uh, take A equal to R sine of suppose alpha plus k1 theta and B equals to R sine of alpha plus k2 theta, and C and D are k3 theta and k4 theta basically. So what this gives us is R sine of, so this all belongs to integers as we have seen earlier, where k1 comma k2 belongs to any z, because see basically if k k1 and k2 which we have taken earlier are equal to 0 1 2 3 up to k, then we are done. And because k plus 1 into theta is basically 360 degrees, so any value of k1 and k2 would work. So what we do is subtract two of them, alpha plus k1 theta minus r sine of alpha plus k2 theta upon r sine of alpha plus k3 theta minus r sine of alpha plus k4 theta. The motivation for dividing is that dividing cancels the factor of r. So this should belongs to a rational number. So this is a rational number. So using basic algebraic manipulations, this becomes twice of from this twice of cos of a minus a plus b by 2. So alpha plus k1 plus k2 by 2 into theta and sine of k1 minus k2 by 2 theta upon twice of cos of alpha plus k3 plus k4 by 2 theta and sine of k3 minus k4 by 2 theta. This is basically what we get, and this should be a rational number. So this expression is a rational number. So let me bring it this side. Yeah, so this is a rational number as we have proved. So notice that this satisfies for any k satisfies this k, any k1 k2 satisfy this. So what we do, we take, so basically we have to eliminate alpha from this expression as I have stated earlier. So to eliminate alpha, what we do, we take k1 equals to k and k2 equals to 1. So what this basically gives is that 2 can be cancelled. First of all, cos of alpha plus k plus 1 by 2 into theta and sine of, so this gives k minus 1 by 2 into theta. Well, this k is basically the same k I have used earlier. So this case k is the same as this k. So this k I am taking and divided by cos of and what I do, k3 equal to k minus 1 and k4 equal to 2. So this is what I am doing. So the basic reasoning is that k plus 1 by 2, we have a nice expression because we know k plus 1 theta equal to 2 pi. This becomes k minus, and this is k minus 2, I think. Yeah, this is k, and this would become k minus 3 by 2 theta. So notice that these two terms are equal, so I can cancel this too. So I get sine of k theta by 2 upon sine of k minus 3 by 2 theta, and this belongs to q as I'm telling. So using k plus 1 into theta equal to 2 pi, we can get that k theta equal to 2 pi minus theta, and k minus 3 into theta equal to 2 pi minus 3 theta. This is what we get. Okay guys, sorry, a small mistake here. This should be k minus 1 theta, and so that was the mistake I was doing the whole time. So yeah, so this would also become k minus 1 theta. So k minus 1 theta, let's do it quickly, is equal to 2 pi minus 2 theta, and k minus 3 into theta would be equal to 2 pi minus 4 theta. This is what we get, and using this 2, we can write that divided by 2, divided by 2, divided by 2, and divided by 2. So sine of k minus 1 by 2 theta would be equal to sine of pi minus theta, and this would be sine of k minus 3 by 2 theta would be equal to sine of pi minus 2 theta. This is what we get, and this is in division, so this is also in division. So this could be easily manipulated as this belongs to q, and this is equal to sine theta by sine 2 theta belongs to q, and because this belongs to q, we can basically reciprocate it. We can write sine 2q by sine q, sine 2 theta by sine theta belongs to q, and this would imply 2 cos of theta belongs to q. 2 cos of theta belongs to q, then this implies that cos theta belongs to q, and cos theta is a rational number. This is what we get here. And what is theta? Notice that theta is 2 pi by n, as we have shown earlier. So theta is 2 pi by n, and 2 pi by n, the cos of 2 pi by n should be a rational number. So let us move to the question now. Yeah, what was the question? So question basically needed to prove that n is greater than equal to 7 doesn't work, and 5 works or not, we need to see. So if we put n equal to 5, n equal to 5 gives theta equals to 2 pi by 5, and clearly this is 72 degree, and cos of 70 degree is not rational, so 5 is not frameable. This is what we conclude. And notice that if cos of 2 pi by n belongs to a q, this the only solution to this is n equal to 1, 2, 3, 4, and 6. These are the only solution. This is a well-known result. If you want to see how it's proven, type Nevin's theorem. This is known as Nevin's theorem. The proof of Nevin's theorem is pretty hard, so I'm not doing it here. Or you can also search algebraic number theory, algebraic integers to be specific. There's also a proof of this statement using algebraic integers. So alright guys, this was the solution. So n equal to 1, 2, 3, 4, 6 are the only possible cases, and I have shown construction for 3, 4 and 6. 1 and 2 would of course not work because polygons cannot be formed using 1 and 2 sides. So these are the complete set of solutions to n is greater than equal to 7 doesn't work. So thanks.